Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and in today's video we've got a simple little task of putting a cutting edge on this piece of 3" by 4" steel. The purpose of this is to make a guillotine blade. Now don't panic, don't leave yet. I'm not going to be chopping animals' heads off or anything. There'll be a whole series coming up after this on demonstrating or building the guillotine itself, and in that I will describe and demonstrate its purpose. But for right now, we want to just concentrate on getting this edge on here. And it's not as simple a matter of just holding it up to the grinding belt and grinding both sides. I want to put as much of a precision angle on this as I can. Let me show you right quickly where this will go. Alright, here's what I want to attempt to build over several videos. Simply a base, 2 uprights, the blade that we're going to work on today, and this air cylinder. This is a piece of new old stock Bimba stainless steel air cylinder. It is a 1.5" with a 3" throw. The item we're going to be cutting, of course, will go right into here. If you recall from some of my previous videos, the little program that I wrote called Machinist Applets, which has several different applets in there. One of those applets was the taper calculator. Now, what the original intent of that taper calculator was to take something like this MT3, where you've got the large diameter down here, you've got the small diameter on this end, and you've got a length in between. And from that you could determine the angle to set your compound to cut this taper. I'm pretty sure that same logic can be applied to cutting a taper on a flat edge. If you looked at this in 2-dimensional, as you're seeing it here, it basically would be the same thing as putting an edge here, a taper here. So if we take our calipers and measure the thickness of this, we come out with 0.159. That was probably a 1/8 inch piece before I cleaned it up. 0.159. So we'll make a note of that as what we'll call the large diameter. Now we want to bring that out to a taper. I'm going to call the small diameter just 0.002, just to give it a value. And we want a length of this of 1.5 inches, half this. So we've got if it was a piece of round stock, we would have a taper of 0.159 at the large end, 0.002, 0.002 at the small end, for a length of 1.5 inches. So let's turn over to the computer now, and I'll quickly show you the taper calculator, which will form the angle or tell us what the angle is. And then we'll do 2 new steps for the Machinist Applets, 2 new applets that I've added to that program. Alright, another quick thing before we turn to the computer. Now, to get that edge on there, we're going to use the surface grinder. But we need to know how to set up the sine plate. What we'll be doing at the computer is not only figuring the angle, but we'll figure out the height, the gauge block height. Gauge blocks right here, I'm sure you're familiar, many called Joe blocks. We'll determine that height to set the sine plate, lock it down, then go to the surface grinder and mag chuck the sine plate down and grind our cutting edge. Okay, here we have our Machinist Applets program again. I'm not going to go into any changes I've made. You'll see a few of them, but we'll cover that in another video. We're going to use the taper calculator, and we set our large diameter or our large width. It was 0.159. Our small was 0.002, and we want to carry this for a length of 1.5. We calculate, we see that our taper angle should be 2.9957. Now, let's go over to the page 2. Again, these will be new apps that I've added to this program. We're going to use the sine bar calculator. Now, my sine bar or sine table is 5 inches. The angle we just calculated was 2.9957. That tells us we need a gauge height for the sine bar of 0.2613. Now we'll build that out of Joe blocks or gauge blocks. To see which ones we need, let's come down to the gauge block builder and put in our 0.2613. And that tells us we need blocks of 0.1003, 0.111, and 0.050. We add those three together, it'll come to 0.2613. So let's go back to our gauge or to our sine bar and get that set up. All right, we're back from the computer now, and before we actually set the gauge blocks in here and set this up, we want to go ahead and mount this, our workpiece, to the sine plate. I can't necessarily put this workpiece up against the back fence back here. That would be cutting it too close, trying to cut that edge right there. So I'm going to bring it on out here. But to keep it all, excuse me, but to keep it square, I'm going to use some 3-inch parallels lengthwise. And I have checked them, and they're close enough to the same length. They're all practically identical. Might be a thousandths off, but in any case, plenty fine for this. And that's going to let this edge hang off just a little bit right here. We'll take our toe clamps, we don't want to get it too close to our 1.5-inch line. We want room for the grinding wheel. Now our workpiece is up tight against the fence on the sine plate, and the back of the sine plate will be pushed up against the fence on the mag chuck. All right, so let's build our Joe block stack. Now our stack said the 0.1003. 0.1003 is right here. I'll lay that one out. 0.111 right here and the 0.05 right here. So we should be able to take these 3 Joe blocks, gauge blocks, and ring them together. The idea of ringing them together is that you get them so close together that there's not even any air between them, and that forms a suction. They don't necessarily have to be rung together, but that is the most accurate way of building your stack. Alright, so now we've got our stack. Having a little bit of issue getting them rung together this morning. The humidity has got to be close to 95% today, but that's going to be plenty close enough. But what I'm going to do is carry this over to the surface grinder, get it in place, then we'll set the Joe blocks in there and tighten the clamps down. Alright, we've got our sine plate mounted on the mag chuck now. Of course, we've got our workpiece mounted on the sine plate mounted on the mag chuck up against the fence. And we've got the Joe blocks in and got them snug. Now I'd like to ask you guys a question. Let me know in the comments. When you're using gauge blocks like this in a sine plate and got it locked down, do you leave the gauge blocks in place or do you take them out? I'm inclined to leave them in place just in case anything starts to slip, but let me know down in the comments how y'all do it. If you leave them in like I'm fixing to do, you want to keep an eye on them and be sure they don't vibrate out or leave you, especially if doing this on a mill. Now I've got that line back here. The idea is when I get to that line, pretty close to it, I should be about halfway this edge down here. That is if I know the calculations are correct, but I'm not sure if the logic is correct of using the taper calculator for a round device versus this flat edge. Now that's as far back as I can go. I like to pass the whole wheel over an item, but we'll see how this works. Everything's clear. give the surface grinder a couple minutes. I've already had it powered up earlier this morning, dressing the wheel. But I want to give it a minute or two running now to let the oil circulate. Alright, it doesn't look like that piece is exactly flat. Okay, we're almost to the mark that I put halfway back there. As a matter of fact, on this edge over here, it just passed the mark on this last pass in. And it's not quite touching over here yet. I'm not sure whether one of the fences is just not straight or if this piece maybe was a little thicker on one end. But let's come down. I'm going to try 2 more thousandths. Alright, that just took the line out at the halfway point. And it just dawned on me why it may be hitting this edge over here first. I didn't check the squareness of this piece. I just assumed it was square. But let's set the, remember I said this thickness to begin with was 159 thousandths. Half of that should be about 80 thousandths, just shy of 80 thousandths. I'm going to set the calipers at 80 thousandths. And that is just going on. Maybe going on at 20 or 30 thousandths up. So I'm going to stop right there. And I'm going to zero out the DRO. This little cheap DRO that I have on here. Flip this piece over and then grind back down to the DRO, read 0, or I get into that line. So let's see if I can, I'll see if I can get to this without taking the sine plate off of the mag chuck. Flip it over and I'll bring you guys back when it gets set back up. Okay, I'm set up on the other side, and I think if this was on the lathe or the mill, I would be calling that chatter. But of course the workpiece is clamped on the back side at about a third the width. So on this outside edge right here, I was getting on the other side, on the beginning side, just a little bit of chatter, just a tiny bit. And I'm getting a little bit now, but of course it's not even touching the sine plate on this side because we cut the angle on it. Now I've got about 80 thousandths to go here, and I'm getting 2 thousandths each time on the drop. So that's 40 passes I've got to make. I'll bring you guys back when we get a whole lot closer. Okay, this pass right here that I'm fixing to make is going to zero out the DRO, bring it back to 0, and it looks like it's going to be dead on our line again. After I make this pass going in with the workpiece, I'm going to make several spring passes back and forth, or spark out passes back and forth. As I said earlier, I'm getting a little bit of chatter here, but what I did was take some of this banding strap, 2 thicknesses of it, and just eased it up underneath that edge there to give it a little bit of a surface to sit on. Yep, that's taking out the line now. Alright, as I said, I'm going to make several spark out passes back and forth on the piece until, as you can see, that a little bit of spring that's in that now, that should have sparked out after 1 or 2 passes. It's getting less and less each time, but I'm going to let that run until it's cleaned up that chatter looking on the top and has sparked out. And then we'll meet back over at the workbench and do a quick little recap on this cutting edge. Well folks, I'm kind of pleased in the way that turned out. As I said, I got a little bit of chatter, especially when I went to the second side, but put a couple shims under the underside, and that seemed to hold it steady. Alright, some of you may be wondering why on the blade I didn't make that at an angle like you ordinarily see on a guillotine. But if I did that, the blade would have to pass all the way through the base until the short side could make the cut as well. I'm hoping with what I've got to cut here that I can go with a straight edge, and in this base just maybe give it a 1/4 inch, 3/8 of an inch relief for this to pass down into base but not go through. If it doesn't work like that, I can go back and cut this at an angle, regrind the edge, and open a slot up in the base so it can pass all the way through. Quick recap on what we did over at the computer. We measured the thickness of our piece and we came at 0.159, and I said I wanted to leave just a little bit of edge here, 2 thousandths. I'm not going to sharpen this down to a razor edge or as sharp as I can get it. I'm not going to do that until I get the whole project built. That'll be the last thing because I'll be handling this a lot. So we said we wanted to come down 2 thousandths, and we wanted 1.5 inches back. So I went to the taper calculator, and this was the only thing I wasn't certain of was going to work on a flat piece. But we put in our large measurement as 0.159, our small is 2 thousandths with a length of 1.5. That gave us an angle of 2.9957. We carried that over to the other applet called the sine bar calculator. My sine plate is 5 inches. We put the angle in of 2.9957 that we calculated up here, and that told us we needed a gauge block height of 0.2613. We then went to the gauge block builder applet, put in 2613 as the height, and it returned back these 3 gauge blocks that were needed to build that stack. Hope you folks have enjoyed this little segment on grinding the blade. Please stay tuned to the channel. Even though the final use of the guillotine that I'm building might not interest you, it will some of you, I'm sure. But even if it doesn't interest you, I think you'll enjoy watching the build. What I'm going to do is actually go ahead and build each part, put it together, filming each part. But what I'll do what I call here on this channel a reverse build. I'll show you the end product and then show you how each piece was machined, fabricated, or whatever to get to that end result. So stay tuned, and I'll see you on the next video.